Alright, so this part is chi-squared test for homogeneity. Like I said, not much actually changes at all here. When we are using it, or what information we are given, is really the only thing that is different. So we said it's independent if we are given the information how. As how many from what? One sample from one population. So I just say, hey, here are these individuals. That's it. If it is this one, I am going to separate them in my selection process somehow. I am going to go out and take a sample of boys, and then I'm going to go out and take a sample of girls, and then I'm going to ask them all the same question. How I got them was different. I didn't just go get people and record gender and variable. I went and took I already split them first and then took only one variable. So when you either take, I don't like writing it as two samples from two populations because that sounds weird. When you separately sample from different populations, so if you want to think about that as taking two separate samples, that's fine. But the only reason I don't write it that way is because if we are doing an experiment and we assign them two treatments, it is considered homogeneity. Which makes sense because it's not like I take somebody and then say, okay, which process did you use? It's the one I gave them. So we already talked about this part of it. There is no difference in the distribution of a categorical variable or did I write several or separate when I wrote it on the 4-step? Different. Okay, I just want to write it the same way. Different populations or treatments.
Where'd you write that name?
Yeah. And then same thing filled in here because it's is instead of it's not. And this bottom part is just saying the same thing we just said. It's used to compare samples from two or more populations or treatment groups. So the whole process is actually the exact same. In the 4-step, what's the first thing that actually changes? In the 4-step, what's actually very different about them? If I look at that piece of paper, where did I split it?
I'm gonna see.
So what I actually write for the null and alternative hypothesis is different. What's the other part other than state that was different? Which is obvious because you're telling me what it is. The method. And I know I only have one more, but I'm writing this too. Conclude is obviously going to be different. Why? It's just filling those in. Whatever you're filling in is different. And the only other thing that, whether you call it different or not, if we've got two different samples or two different treatments, we're going to have to like check the 10% condition for more than one group. So we're going to do the math again.
Wait, 10% condition has more than one Y.
Like where I have to do N1 and N2 because I have at least two different groups for two populations. Everybody calculators out. So all of the math that we did on the front page, your calculator does for you. But if you don't know how to do it in pieces like I did on the front, then you're not going to be able to answer the multiple choice that comes with it. So in your calculator, there is what is a two-way table actually in math called? It's not a list, it's a what? A matrix. So there is a button on your calculator for matrix. You can look at it, it's in blue. So below math, so second, go to where it says matrix. And right now it's just going to give us these. Well, we want to edit one of these. So go to edit and just click on it. And it should give you something that looks like this unless yours already had something in there. So second, matrix, edit. And I just clicked on A. So as you change the numbers, and to be honest, I never remember, well, I do now, but if you don't remember which one it is, if I think it's like, if I type 3 by 4, it's going to show me which direction it goes. Or if I switch and do 4 by 3 up top, then it's going to give it to me like that. So you don't have to memorize like which one's which. Just hit enter and see if it's the right one. But the matrix I'm trying to type in for this example is a what by what? How many do I have across the top? So it's 2 across the top. How many across the side? 3. It's actually rows first. So it's 3 by 2. So it gives me my setup to type them in, right?
Well, which list are we looking at?
You just click on A. You edit A. Oh, the one on the side, like right below where we are.
Like the actual chart or all the numbers?
The only one on that page that gives you numbers.
That's not. We don't put total in there.
You don't put total in there. Okay. All right. So what's my first number to plug in? 14. So type 14 and hit enter, and it'll send you to the next one. Then type 10 and hit enter, and it'll send you to the next row. So you're just typing them in. And so I've got all of my information typed into matrix A, right? Now I'm going to leave this and use it later. So we are running a what? In general, we're running a test. So where do I always go to do a test? Stat tests. Well, I've got all these options that say test, and then it switches and goes to interval. Keep going. And then below all my typical tests and intervals, I get this thing right here, which is chi-squared, which is where we are. Have I used any letters that say GOF today? Then it's probably not what we're using today. So you are going to see and it asks you observed, expected.
Which one did you pick? G?
C. Where are my observed? A. It is actually going to do your expected for you. It is asking you where you want it to put them. So you just leave that as A and B and then hit calculate. And it now gives you the chi-square statistic and your p-value and your degrees of freedom. But it did the expected for us and made it and left it there. So if we wanted to go look at it, we go back to matrix. And you see that you now have something in B. And then just hit enter and click on it. And you'll have to hit, like you hit it once and it says this, and you hit it again and it'll actually do it for you. Those are the counts for your expected.
You also need to do steps. I found the degrees freedom and all that stuff.
Okay, so then you just completely go away from it and then go to, I'm going to a matrix. It puts something in B for me, so I just click on B and hit enter twice.
Why do we have to go?
Because it made it and put it there for us. So in our conditions, I'll need to write this down to be checking that my expected counts are greater than or equal to 5. But it does all the math for me. So if I ask you, how much did lithium no contribute to the chi-square statistic, you would have to go and actually calculate that one because the calculator doesn't keep up with that in pieces. That's why you had to know how to do it by hand the first time. Questions right now? So what do I have left on here? Nothing. I am going to start talking about one of your homework problems, and you should be fine. And I might post an answer key for a different problem online if you want to follow it. So flip it on the back. Nope, you don't have the sheet, do you? All right, so I'm going to talk about this one. Y'all don't have this one, sorry. Random digit dialing telephone surveys used to exclude cell phone numbers. If the opinions of people who have only cell phones differ from those of people who have landline service, the poll results may not represent the entire population. The Pew Research Center interviewed separate random samples. So this right here to you should immediately tell you what? It's random, the random selection, and which one of the two are we doing? The front sheet or the back sheet? Did we take one sample from one population? We're taking separate samples from this and from this. Do you see that? So how many samples are we taking? So which kind of chi-square test is it? Homogeneity. That's the only difference that tells you that you're on the back side of the sheet instead of the front. Did it take one sample or did it take multiples? So that one line is telling me that it is homogeneity and I'm doing that process instead, but the math is all the same. So for this one, our null hypothesis, what is our population here? I know you don't have it in front of you, but you should be able to look up here and see. What is our population? Who did we interview? Who are our individuals? Continue.
Who are less than 30 years old.
So our population is phone users who are less than 30. And then our null hypothesis on the back would be what? I'm reading from this piece of paper. Null hypothesis. There is no difference in the distribution of. So what are my separate samples? Cell users, cell only users, and landline users, right? What am I measuring from those different populations? So this one would be, there is no difference in the distribution of political affiliation for cell only versus landline users. Does that make sense? The entire 4-step process is the same regardless of if you're using independent or homogeneity.